Hello friends, welcome to Bindu Dhadwal chemistry lessons. The topic that we take today is chemical bonding and molecular structure. Cossel-Lewis approach to chemical bonding. Cossel and Lewis studied the noble gases and found that noble gas elements present in group 18, they are called zero group elements because their valency is zero and their atoms can exist independently. For example, helium configuration is 2s2 2p6, second shell is complete. Similarly, argon's third shell is complete, 3s2 3p6. Krypton shell 4 is complete. So in 1916, G.N. Lewis and Cossel stated the Octet Rule. The atoms of different elements take part in chemical combination in order to complete their octet or duplet. This rule is called the Octet Rule. In the formation of molecules, only the electrons present in the outermost energy shell or valence shell of the atom normally participate, while the electrons belonging to inner shells are not involved in bond formation. So Lewis introduced symbols to represent valence electrons of atoms. These are called Lewis symbols. These are also called electron dot symbols or simply dot symbols. For example, the electronic configuration of lithium is 1s2 2s1. So in the valence shell it's having one electron. So we write the Lewis symbol for lithium as lithium and 1 dot. Similarly, beryllium's configuration is 1s2 2s2. So this last shell or valence shell configuration is shown in the form of 2 dots, rest is shown in the form of beryllium, Be. Similarly, for boron, we write B and 3 dots because outermost shell contains 3 electrons, 2 in 2s and 1 in 2p. Carbon has 4 electrons in its valence shell, so 4 dots are shown. Nitrogen has 5 electrons in its valence shell, 5 dots with symbol of nitrogen. Similarly, in oxygen, we show 6 dots. In fluorine, we show 7 dots. 1s2 2s2 2p5 is the outermost shell configuration, 7 electrons. And in neon, there are 8 electrons, 2s2 2p6. So 8 dots are shown. Significance of Lewis symbols. Symbols represent the number of valence electrons, and from the electrons we can also calculate the valency or group valence, and valency is equal to number of dots in the symbol or 8 minus the number of dots. For example, carbon has 4 dots, that means its valency is 4. Nitrogen has 5 dots, so valency will be 8 minus 5 is equal to 3. So valency will be 3. If the number of dots are more than 4, then you find the valency by subtracting the number of dots from 8. Modes of chemical combination. Lewis and Cossel gave the electronic theory of chemical bonding, in which they stated that elements can form bonds in 2 manners: by electron transfer from one atom to another, then ionic compounds are formed and bond formed is ionic or electrovalent bond, and second is by sharing of electrons, then the bond formed is covalent bond and the compounds are covalent compounds. First we will do ionic or electrovalent bonds. For the formation of ionic or electrovalent bond, a metal which has tendency to lose electron will lose electrons to form cation. The non-metal atom will gain electrons to form anion. These cation and anions are oppositely charged and attract each other and thus form a bond which is called ionic bond because it is between ions. So ionic bond may be defined as the Coulombic or electrostatic force of attraction which holds the oppositely charged ions together. Formation of sodium chloride. तो सोडियम की इलेक्ट्रॉनिक कॉन्फ़िगरेशन है 281 सेकेंड शेल कंप्लीट हो जाएगा अगर सोडियम एक इलेक्ट्रॉन लूज कर देता है। और इसी तरह क्लोरीन की इलेक्ट्रॉनिक कॉन्फ़िगरेशन है 2871। तो अगर इसको एक इलेक्ट्रॉन मिलता है तो इसका आउटरमोस्ट ऑक्टेट कंप्लीट हो जाएगा, आउटरमोस्ट शेल का ऑक्टेट। तो सोडियम अपना इलेक्ट्रॉन क्लोरीन को दे देता है, इसका भी ऑक्टेट कंप्लीट हो जाएगा, 28 हो जाएगा, और इसका भी कंप्लीट हो जाएगा 288। आफ्टर गिविंग इलेक्ट्रॉन सोडियम पे आ जाता है पॉजिटिव चार्ज, ये बन गया सोडियम केटाइन। क्लोरीन जो है एक इलेक्ट्रॉन उसने गेन किया इसलिए उसके ऊपर नेगेटिव चार्ज आ जाता है, तो वो बन जाता है क्लोराइड आयन। अब ये ऑपोजिटली चार्ज्ड आयन्स हैं, ये एक दूसरे को अट्रैक्ट करेंगे और जो फोर्स ऑफ अट्रैक्शन है उसको हम आयनिक बॉन्ड कहेंगे, और जो कंपाउंड है उसको हम आयनिक कंपाउंड कहेंगे। इसी तरह कैल्शियम फ्लोराइड में, कैल्शियम के आउटरमोस्ट शेल में 2 इलेक्ट्रॉन्स हैं, 2 फ्लोरीन एटम्स हैं, दोनों के आउटरमोस्ट शेल में 7 इलेक्ट्रॉन्स हैं, और एक एक इलेक्ट्रॉन इनको चाहिए है। तो कैल्शियम का एक इलेक्ट्रॉन इस फ्लोरीन एटम को और दूसरी फ्लोरीन एटम को जाता है, ट्रांसफर हो गया। एज अ रिजल्ट कैल्शियम के ऊपर डाई पॉजिटिव चार्ज आ गया, कैल्शियम 2 पॉजिटिव बन गया और उसका ऑक्टेट कंप्लीट हो गया। दोनों फ्लोरीन एटम्स ने भी एक एक इलेक्ट्रॉन गेन किया और फ्लोराइड आयन बनाया, इसका भी ऑक्टेट कंप्लीट हो गया। और ऑपोजिटली चार्ज्ड आयन्स एक दूसरे को अट्रैक्ट करके ये कंपाउंड बनाते हैं कैल्शियम फ्लोराइड, जो कि एक आयनिक कंपाउंड है। इसी तरीके से फॉर्मेशन ऑफ मैग्नीशियम ऑक्साइड में मैग्नीशियम की कॉन्फ़िगरेशन है 282, ऑक्सीजन की है 2 and 6, यानी ये इलेक्ट्रॉन्स ट्रांसफर हो जाते हैं। एज अ रिजल्ट मैग्नीशियम पॉजिटिवली चार्ज हो जाता है, 2 पॉजिटिव चार्ज आ जाता है, और ऑक्सीजन के ऊपर 2 नेगेटिव चार्ज आ जाता है। दोनों ऑपोजिटली चार्ज्ड आयन्स एक दूसरे को अट्रैक्ट करते हैं, जो बॉन्ड बनता है उसको आयनिक बॉन्ड कहते हैं, और कंपाउंड को आयनिक कंपाउंड कहते हैं। वो इलेक्ट्रोवैलेंसी इज द नंबर ऑफ इलेक्ट्रॉन्स विच एन एटम ऑफ इट आइदर लूजेस और गेन्स इन द फॉर्मेशन ऑफ आयनिक और इलेक्ट्रोवैलेंट बॉन्ड। फैक्टर्स इन्फ्लुएंसिंग द ionic bond formation. Ionization enthalpy. Ionization enthalpy is the energy required for an atom to lose its most loosely bound electron in the gaseous state. जितनी कम ionization energy required होती है उतने ही आसानी से cation बनता है. So lesser the ionization energy required, easier will be the formation of cation. It is the amount of energy released when an atom, a neutral gaseous atom, gains electrons to complete its octet. Greater the negative electron gain enthalpy, easier will be the formation of anion. Lattice enthalpy. What is lattice enthalpy? It may be defined as the energy released when 1 mole of a crystalline solid is formed by the combination of oppositely charged ions, and it is denoted as U. So greater the magnitude of lattice energy, more will be the stability of ionic bond or compound. This lattice enthalpy or energy depends on 2 factors: size of ions. Smaller the size, lesser will be internuclear distance, and greater will be the lattice energy. Charge on the ions. Larger the magnitude of charge, greater will be the attractive forces and higher will be the lattice enthalpy. General characteristics of ionic compounds. Physical state. Ionic compounds generally exist as crystalline solid in which oppositely charged ions are closely packed in space. The arrangement is known as crystal lattice. Melting and boiling points. Because of presence of strong interionic forces, the ionic compounds have high melting and boiling points. These are poor conductors of electricity in the solid state because ionic mobility is nil. However, they become conductors in molten state or in aqueous solutions. Solubility. They generally dissolve in polar solvents like water. Polar molecules interact with ions of crystalline solid and release hydration enthalpy. The energy released overcomes the interionic forces between the ions, and ions get separated and dissolved. Ionic reactions. These ionic compounds undergo ionic reactions which are very fast, formed by sharing of electrons, which is called covalent bond. So different theories have been put forward to explain the formation of covalent bond. These are Lewis-Langmuir theory, valence bond theory, and molecular orbital theory. Let us do Lewis-Langmuir theory. Covalent bond is generally present in atoms of non-metals. Is defined as the bond formed between two atoms, maybe same or different, by mutual contribution and sharing of electrons. So if the combining atoms are same, then the molecule formed is homoatomic molecule, and if the atoms are different, then the covalent molecule is heteroatomic molecule. Homoatomic molecules, for example, hydrogen molecule. Each hydrogen atom has one electron in its first and outermost shell, and it needs one more electron to complete its duplet. So both contribute one electron each towards sharing. So in all, 2 electrons are shared between the atoms, a single bond is formed, and hydrogen molecule is obtained. Chlorine molecule. 2 chlorine atoms, each having 7 electrons in its outermost shell, need 1 electron to complete its octet. So they both contribute 1 electron each. So these are the shared electron pairs. As a result, a single bond is formed. Chlorine molecule is formed. The electrons which are not shared are called lone pair of electrons. Oxygen molecule is formed between 2 oxygen atoms, each having 6 electrons in their outermost shell. Now both the atoms need 2 electrons each, so both contribute 2 electrons to sharing. So 2 by this oxygen and 2 by this, in all 4 electrons are being shared, so a double bond is formed. The nitrogen molecule has 5 electrons in its outermost shell, needs 3 more. So both the atoms will contribute 3 electrons each for sharing. As a result, a triple bond will be formed and the octet is completed. 6 electrons are shared and 2 electrons are lone pair. Heteroatomic molecules. So in case the combining atoms are different, we get the molecules heteroatomic. For example, water. 2 hydrogen atoms and 1 oxygen atom. Hydrogen needs 1 electron to complete its duplet. Oxygen needs 2 electrons to complete its octet. So both the hydrogen atoms will contribute 1 electron each towards sharing, and oxygen will contribute 2 electrons in all, 1 with this hydrogen, 1 with the other. So methane molecule has 1 carbon with 4 electrons in the valence shell, 4 hydrogens each having 1 electron and needing 1. So they contribute 1 electron each. In all, 4 single bonds are formed between carbon and hydrogen atoms, and methane molecule is formed. In ethylene molecule, there are 4 hydrogen atoms and 2 carbon atoms. So carbon atom contributes 1 electron to bond formation with hydrogen, 1 with the other, and 2 electrons with the carbon atom. Single bond is formed and 2 electrons between each carbon-hydrogen bond. So a single bond is formed. This is the ethylene molecule. Similarly, ammonia molecule, a heteroatomic molecule, contains 3 hydrogen atoms and 1 nitrogen. Nitrogen needs 3 electrons, it has 5. Each hydrogen needs 1. So a single bond is formed and ammonia molecule is formed. This is the lone pair of electron. These 3 are shared pairs. Then phosphorus trichloride has 1 phosphorus and 3 chlorine. Chlorine atoms have 7 electrons in the outermost shell. Phosphorus has 5. So 3 chlorine atoms need 1 electron each, so contribute 1, and 1 is contributed by phosphorus. A single bond is formed. Each one gets its octet. So as a result, a stable PCl3 covalent molecule is formed. 1 hydrogen, 1 carbon and 1 nitrogen. Nitrogen needs 3 electrons. So carbon and nitrogen will contribute 3 electrons each for bond formation and form a triple bond. And hydrogen and carbon will contribute 1 electron towards bond formation and form a single bond. Formation of carbonate, there is 1 carbon and 3 oxygen atoms. With 2 oxygen atoms, carbon is contributing 1 electron towards bond formation, whereas with 1 oxygen it's contributing 2 electrons. In all, 4 electrons are being shared here and 2 each are being shared with the other oxygen atom. So there is a double bond here and a single bond here. Double bond with 2 oxygen atoms and single bond with 2 oxygen atoms. 4 electrons are being shared here where there is a double bond, and 2 electrons are being shared where there is a single bond. Overall, there is a 2 negative charge on the sulfate ion. Similarly, in phosphate, there is 1 double bond and 3 single bonds. So overall, there are 3 negative ions. For ammonium ion, 1 nitrogen, 4 hydrogens with 1 electron each. As a result, one of the hydrogen is without an electron. So overall, there is 1 charge on the ammonium ion.